Before we get started on the lesson today, are there any questions over any of the assignments thus far? So what we're looking at today is the factor theorem. Now the factor theorem, we have all this here. It's just saying if we divide a polynomial and get a remainder of 0, it means whatever we divided that polynomial by is a factor of it. And that works with anything. We could say 2 and 126. Because if we did the division, 2 goes into 12 6 times. 0, bring down the 6. 3. So the remainder is 0, which means 63 is a factor of 126. They're factors if we get a remainder of 0. The same thing is true with polynomials. So if we divide this polynomial, x squared plus 2x minus 4, by x minus 2, and get a remainder of 0, it means that this is a factor. So we can do this with synthetic division. So when you set x minus 2 equal to 0, to get our number that goes inside the cubbyhole. So the first thing we can do is add 2 to both sides, telling us x is equal to 2. And now we can put the numbers across the top. So we would have 1 for x squared, 2 for x, and negative 4. And we'll bring down the 1. And now we'll do our multiplication. So 2 times 1 is, we'll put it under the next number, 2 plus 2 is. And we do 2 times 4, which is, and negative 4 plus 8 is. And 4 here is our remainder. So is x minus 2 a factor of x squared plus 2x minus 4? For it to be a factor, the remainder has to be 0. If the remainder is 0, it is a factor. If it's not 0, then it is not a factor. Any questions on this so far? All right, guys, we'll look at the next one. On this one here, we want to determine if x plus 5 is a factor of 3x to the 4th plus 15x cubed minus x squared plus 25. So we can do our synthetic division. Next page, the page has got a little bit out of order. Now the first part here is to solve this for x, so we would minus 5 from both sides, telling us x is equal to negative 5. Now the numbers that go across the top, our first one would be 3, then 15, negative 1, and then there's not an x. So we have x to the 4th is the biggest one we have, so we need x to the 4th, x to the 3rd, x squared, x, and our constant term. And it works out the numbers that we have going across the top will be 1 more than the degree. So the degree for this is 4, so we need 5 terms. And we have 1, 2, 3, 4, 5. We'll drop the first number down. Then we'll multiply. Negative 5 times 3 is negative 15. 15 plus negative 15 is. Then we'll multiply. Negative 5 times 0 is 0. Negative 1 plus 0 is negative 1. Then we'll do negative 5 times negative 1, which is positive 5. 0 plus 5 is. And lastly, negative 5 times 5 is Negative 25. And 25 plus negative 25 is? Yes, this is a factor. Because it is a factor when the remainder is 0. So if we wanted to rewrite this out, we can put the variables back in. Now this is our remainder. Our 5 would be our constant term, our term without x. The negative 1 would be the term with x. The 0 would be the term with x squared, and 3 would be the term with x cubed. So what we have is 3x cubed minus x plus 5 is being multiplied by x plus 5. Because when we multiply these two together, we would get back to what we started with, because those are the factors of it. Any questions on any of this here? Let's look at the next one. The next one, we want to determine if x minus 3 is a factor of x squared plus 6x minus 12. So to get x by itself, we would add 3 to both sides, so minus x is. Across the top, we'll have 1, 1, 6, negative 12. We'll bring down the 1. Then we'll multiply. 3 times 1 is. Then we'd add straight down. 6 plus 3 is. 3 times 9 is. And negative 12 plus 27 is. So is this a factor? No, it's not a factor because the remainder is not 0. Questions on any of these here? We need to see another example of one of these. You feel pretty good with these here? If that's the case, we'll go on and move on. Because I do include more in there just in case y'all need to see more examples or see more done, but we don't have to do those. So this is on the back page, very back page right before the homework, and it should be at the bottom. Yes? So after we do this one, we're going to go back to the back of the first page for the last two. Now, when we look at this here, we want to show that x plus 3 is a factor of this polynomial here. So we can still do synthetic division. The first thing we can do is set x plus 3 equal to 0. Then we would so across the top, what's the degree of our polynomial? 4, yes? So how many terms should we have? How many terms are listed up there? 4. So we know we need a 0 because we need 5 terms total. Everybody good with that? So what's the degree of this? So how many terms should we have? How many terms do we actually have? So we should have 1 as a... So we have 1 for x to the 4th, 3 for x to the 3rd, for x squared, negative 1 and negative 3. Then we bring down the 1. Then we start our process for dividing. Negative 3 times 1 is? 3 plus negative 3 is? Negative 3 times 0. 0 plus 0. Negative 3 times 0. Negative 1 plus 0. And negative 3 times negative 1 is? And negative 3 plus 3 is? 0. Did we expect the remainder to be 0? Yes. Why is that? Show that this is true. Normally, especially in mathematics, when they say show that this is true, it's going to be true. We just have to prove that it is. So that is one of our factors. Now, That's the same as what we did before, but they want us to then factor this completely. They want us to factor it all the way out. So we know a term is factored completely when the degree is 1. So if we plug the variables back in here, we have our remainder. Our -1 is our term without a variable. Our 0 next to it is x. The one after that is x squared. And then we have x cubed. So what we have is x cubed minus 1 is one of our factors. The factor that is being multiplied with is x plus 3. Now we can say the x plus 3 is factored as far as it'll go because the degree is 1 for the x plus 3. Now the other one that we have is our x cubed minus 1. So we need to see if that'll factor. Now we did cover ones like this yesterday, the difference in sum of perfect cubes. So we can check to see, can I take the cubed root of x to the third? And it would be x. And we need to see if I can take the cubed root of 1. Is there something multiplied by itself 3 times that'll give us 1? And it really doesn't matter what it is. We can take the nth root of 1 and it'll still work. As we can say, well, that's like math. So let's do, I'm just bouncing around. That massive number of 1. Still 1. Doesn't matter what root we take. If what's inside of it is 1, it's still going to be 1. So we can take the cubed root of this. So we'll have 3, 2, 3, 4, 5. Oh, try this again. There we go. So 3 spaces and 5. So same, opposite, always end on a positive note. So we know the last side's going to be plus. Now the same, so it started out as minus, so the first one's going to be minus. Opposite would be plus, and then plus. Now we already found the value of a, our first term, which is our x. So in the first space here we would have x. In the first space on the next one we would have x squared, x to the first, and then x to the 0, which is just 1. Anything to the 0 power is 1. But we don't have to include it, so we're tempted to say that, but we can leave it blank. Now our other term, our b value, or our second value is 1. So in the spot here we'd have 1. With x squared we'd technically have 1 to the 0, which is just 1. In the middle we'd have 1 to the first, and lastly we would have 1 squared. So we still have x plus 3. We'd have x minus 1. Well, x squared is just x squared. X times 1 is x, and 1 squared is 1. Now this would be it here. There's 2 reasons that I can say that. One, and the main one, is that x squared plus x plus 1 will not factor. The quadratic part that comes out the sum or difference of perfect cubes will never factor. It just won't. And that's the main reason why I can say we're done. Now, if you wanted to, especially on a test or a quiz, to see if the other one will factor, especially if it's quadratic, one thing we can use is b squared minus 4ac to see if it'll factor to give us whole numbers. Because if we take the square root of that and it gives us a whole number, no decimals, then it actually would factor. Another way we can do it is to graph it. So I can plug in x squared plus x plus 1. I did this in a previous hour, so it's already typed in. And if we hit graph, if it crosses the x-axis, then it has factors. It doesn't cross the x-axis. So that's one guarantee that it doesn't have factors. or really that it doesn't have real solutions. So for this here, we're done. Because again, if they want it factored completely, we look for powers greater than 1. So the x plus 3 is as simplified as it gets because the degree is 1. There's no further way we can take it. X minus 1 is the degree is 1, so we're done. The x squared plus x plus 1, we would look into that, but since we know it's coming from the difference of perfect cubes, it's not going to go any further. Does that make sense? Yes? Okay. We ready for the next one? I mean, for the most part anyways. So we can factor this out. So we want to show that this is a factor, so the first thing we can do here is back of the first page. Yeah, the page just got completely out of order. So that tells us x is 2. It goes in the cubbyhole. Across the top, we would have 1, 2. Yep. The number of terms is always going to be 1 greater than the degree. So here, 2 times 1 is negative 2 plus 2 is 0. 2 times 0 is 0. 0 plus 0 is 2 times 0 is 0. I don't know why I about tried to write 2. 1 plus 0 is, then we have 2 and 0. So it is a factor just like we thought it would be. Now we can put the variables back in. So 0 is our remainder. The 1 is our term without x. So 0 would be the term with x. 0 would be the term with x squared. Exactly. So 1 would be x cubed. Yep. Because if you start off with the 1 being x, it's going to put you 1 higher. Now, what was the degree of the polynomial we were using to divide by? Well, this here is 1, and what we have up here is 4, yes? It always will decrease the polynomial by the degree of what we have, or that we're dividing by. So the degree of what we have for the original polynomial is 4, yes? What we're dividing by is 1. So 4 minus 1 is? So our ending polynomial should be degree 3. It'll always do that. We can decrease by 1 if we use a binomial. And this is part of the reason why we're doing this or go over this, especially when we start solving. Because each time I divide by 1, it decreases it by 1. Because at this point, have we actually figured out a way to solve these higher degree polynomials? Well, no. But if I could decrease that degree from 4 to a 3 and from 3 to a 2, it's now a quadratic. We've gone over ways to solve quadratics, so we can go from there. And that's kind of the goal. Now what they left us with is, well, one of them is going to be x minus 2. What we have here is x cubed plus 1. Our signs are going to be the same. Opposite always end on a positive note. So for it to be the same, we need plus minus plus. Because this time we have x cubed plus 1. So the signs for them to be the same would be plus. Opposite would be minus. Always end on a positive note. Same, opposite always end on a positive note. Now we take the cubed roots. Cubed root of x to the third is going to give us x. And again, the cubed root of 1 is still 1. So our first term, we'd have x. Here we would have x squared, x to the first, then x to the 0. Our second term in the first spot would be 1. Then we'd have 1 to the 0. In the middle, we'd have 1 to the first. And then we'd have 1 squared. So that leaves us with x minus 2 times x plus 1 times x squared minus x plus 1. Questions on this here? And that there is, again, as far as it goes. Now we could look at the graph of this here, which is really just changing it to minus x. Still doesn't cross the x-axis. So this is as far as it goes. Questions on this here? Let's look at one last one, and then we are done for today. So the first thing we'll need to do is get x by itself here. So we would add 6. And again, we're using this to show that x minus 6 is a factor. So 1 for x to the third, negative 5 for x squared, negative 6 for x, and then 0 because we don't have our constant term. Because the degree is 3, we need 4. Yes. And if it was a degree 5? Wherever there's one missing. Because if we look at the polynomial they gave us an x to the third, yes? They gave us an x squared. Did they give us an x? It's negative 6x. So we have cube squared x, and then we need our constant. We have the constant term. So we add it in as. Because any one we're missing, we add back in as 0. Now the first thing we'll do is 6 times 1, which is negative 5 plus 6 is 1. 6 times 1 is? So we have this here. Now the next thing we need to do is put the variables back in. So this here is our remainder. The 0 is our term without x. X, and so really what we have left is x squared plus x. And this here is being multiplied by x minus 6, yes? Now we do need to factor it because the x squared minus, or x minus 6 is as simple as it gets. X squared minus x we need to factor. Because I can look at the graph for this here, clear that out, x squared plus x. Okay, it does cross in 2 different places. So this does have solutions, it does factor. But if we look at these two terms, is there a greatest common factor between these two? We can factor it out. So if I factor an x out of x squared, I'm left with plus x factored out of x is and that's it. Questions on any of this here? We good? That's it. That's all we're covering today.